Now we'll take a look at arithmetic sequences. These are sequences in which there's a common difference between the consecutive terms, meaning that you add or subtract a number to get to the next term. So generally it's the first term, whatever it happens to be, which we write as A, and then whatever that common difference is, D, we add D to get to the next term. So A plus D is the second term. And then we add A plus D plus another D to get the third term. So that would be A plus 2D. And then A plus D 3 times to get to the next term. So that would be A plus 3D. So A is always the first term. For all sequences, we always denote A as being term 1. And D is the common difference. And the way we find it is we take a term and we subtract the previous term. So we could take term 2 and subtract term 1. We could take term n. It could be any number. It could be the last one. It could be somewhere in the middle, term 5, term 8, doesn't matter. And we subtract the one before. So just note with this notation, all of these are subscripts and they need to be written small down below. Don't write it like this, term n, because that would be t times n, which doesn't mean anything here. It must be written as t sub n like this. Okay? And term n minus 1 would be the previous term. Term n would be, let's say, term 5, but term n minus 1, term 5 minus 1 would be term 4. So anytime you see n minus 1 like this, it means the previous term, like term n minus 1. So arithmetic sequences are linear because you're adding the same amount every time. So if you think back to grade 9 math, that is your slope, your rate of change. Generally, the general equation for these looks like this. So we have term n is equal to A, which is our term 1 value, plus n times 1 times D. And remember, n is the term number that matches down here, and we subtract 1. So if we're looking for, say, term 5, then we'd have whatever that first term is. I'm actually going to write it as term 1 because that's the same thing as A, plus 5 minus 1, which is 4 times D. So that is our initial value, term 1, plus 4 times the common difference. Okay? And then the recursive formula, which we'll see, sorry about that, we'll see a little bit more of that in a little bit later. But we always have to say what we start with. So term 1 is equal to A, whatever that number happens to be. And then this is the part you need to remember. Term n is equal to term n minus 1 plus D. So whatever term we're looking for is equal to the term right before it, the previous term, plus that common difference. And this is always true where n is greater than 1. And we can write this as a discrete, remember that term, discrete linear function, f of n, where it honestly looks like y equals mx plus b. So here we have that y-intercept, b, and instead of m times x, x is now n, and our common difference is our slope. I'm going to erase all of this. Maybe that thing will stop popping up. No, there it is again. Okay, and b is term 0, like I said, which is actually our term 1 minus our difference. So keep in mind that anytime we're talking about term 1, if we were to graph it, we're looking at 1 right here, not at 0, which would be like our y-intercept. So term 0 is actually 1 before this, which would be wherever it happens to fall on the y-axis. And just some notation down here. A is always the first term, D is the common difference, and n is the set of natural numbers. N has to be an element of of natural numbers. Hoping this thing will stop saying drawing was undone, but we'll see. All right, so here's some examples. We're going to calculate the first 3 terms of each sequence. And we're given, for the first one, we're given the general equation for some sequence. So for term 1 is equal to negative 2 times n. And again, remember that whatever our subscript down here is, that's our n. So term 1 plus 1. So negative 2 times 1 is negative 2, plus 1 is negative 1. So term 1 is equal to negative 1. Term 2 is equal to negative 2 times n, the term number, plus 1, which is negative 3. And term 3 is equal to negative 2 times the term number, which is 3, plus 1, which is negative 5. So there we have our first 3 terms of this sequence. For our second one, it's in function notation, and you'll notice it's quadratic because we have n squared. F of n equals n squared minus 4. So f of 1, or f at 1, is equal to 1 squared minus 4, which is negative 3. F of 2, or f at 2, is 2 squared minus 4, which is 0. And f of 3 is 3 squared minus 4, which is 5. So there we have the first 3 terms of that sequence. The third one, f at 1 is 1 over 1, which is of course just 1. F of 2 is 1 over 2. And f of 3 is 1 over n, which again is 3. So even though these last two are in function notation, you have to remember that these are discrete functions, which means that they're basically just a series of points on a graph. We do not join them with a line or a curve. Now we're going to look at, are these sequences arithmetic? So if they are, then they would have to have a common difference, something that is being added or subtracted every single time to get to the next term. So if we start with the first one, negative 9, to get to negative 6, we would add 3. To get from negative 6 to negative 3, we would add 3 again, which means because there is this common difference, it is arithmetic. And the common difference d is 3. Another way to find d would be to take any of these ones, so say term 2, and subtract the previous term, term 1. And when we do that, we get 3. And we also have to find the general term. We already have the common difference, d. So the general term, so term n, is equal to a, our initial value, our initial term, term 1, plus n minus 1 times d. So we know our first term is negative 9 plus n minus 1, and we know our common difference is 3. So now we have to simplify this, so we multiply that 3 in to the bracket that's before it. So we get negative 9 plus 3n minus 3, and simplifying further, we get term n is equal to 3n, and negative 9 minus 3 is negative 12. So this is our general term. Let's look at the second one. We have 11, 22, 44. So we could go from 11 to 22 by adding 11. We could go from 22 to 44 by adding 22. There's not a common difference there, meaning it's the same every time, which means it is not arithmetic. Oops. Which means there's no common difference, not arithmetic. We can't do anything else with that, really. Now we're going to determine the 23rd term of this sequence, 4, negative 3, negative 10, negative 17. So from 4 to negative 3, we would have to subtract 7. To get from negative 3 to negative 10, we would subtract 7. from -10 to -17, we would also subtract 7, which means our common difference is -7. Our term 1 value, a, is 4, and we're looking for the 23rd term, which means that n that we're looking for is 23. So over here, I'm going to write the general term equation, and then we're going to sub in what we know. Well, we're looking for term 23. We know that a is 4. N is our term number, so 23 minus 1. And we know d is -7. Very, very, very important to put brackets around it. If we don't put brackets around our -7, it looks like we're subtracting 7 from the everything in front, and that is absolutely incorrect. Do not forget those brackets. And then we're just going to simplify this. So 4 plus 22 times -7. 4 minus 154, which is -150. Therefore, term 23 is -150. Here's another example where we are determining the number of terms in this sequence. We have 8, 11, 14, 17, several more terms, we don't know how many yet, and then 71, which means this is our last term, and it is in fact a finite sequence. So we know that a is 8, because that is our first term. If we look at our pattern here, we're adding 3 every time, which means our common difference d is 3. We know that term n that we're looking for, the n part is what we're looking for. We know that term n is 71, and n, we're not sure yet. We're looking for the term number that is equal to 71, basically. So again, term n is equal to a plus n minus 1 times d. We know that term n is this one right here. So 71 is equal to a is 8 plus, this is the part we don't know, n minus 1. We're solving for n, and then we're multiplying that by 3. So again, we're going to multiply that 3 into the terms inside the bracket in front of it. So 71 is equal to 8 plus 3n minus 3. We're going to simplify a little bit. 8 minus 3 is 5 plus 3n. Bring the 5 to the other side, so we're subtracting 71 minus 5 is 66. And on the on the right side, we still have 3n. Divide both sides by 3, and we get that 22 is equal to n, which means that 22 is our term number, and there are 22 terms in the sequence. And I ran out of space, but that's okay. Another example here, in an arithmetic sequence, term 5 is equal to 16 and term 8 equals 25. Find the first 3 terms and term n. I'm going to show you 2 ways to do this one. We're going to start with what I'm going to call the quick method. In order to find common difference, we would normally take some term and subtract the previous term. So term n minus 1. We don't have 2 that are in order because we have term 8 and term 5. So what we're going to do is recognize that from term 8 to get to term 6 and then 7 and then 8, we're adding that common difference or subtracting it. In this case, adding because the numbers are getting bigger. We're adding it 3 times. So what we're actually going to do here is, in order to get that common difference, we're going to have term 8, and we're going to subtract term 5, and then we're going to divide it by 8 minus 5, or 3, because there are 3 times that we're adding this common difference. So term 8 is 25, term 5 is 16,